Hello viewers, my name is Mr. Kazim and I am delighted to welcome you to my YouTube channel at Smart Edu TV. Here you will find detailed tutorials on your science courses and tips on how to answer examination questions successfully. I started this channel to also share my knowledge and experience in this field and to give you tips on how to succeed as a university student. If you are looking for detailed tutorials on physics subjects, chemistry, mathematics, biology, statistics, and general studies (GST), then you have come to the right channel. So therefore, sit back, relax, and join me on this journey. Don't forget to hit the subscribe button and turn on the notification bell to never miss on an important update. Please remember to also share this video so that others can benefit. Thank you very much. Okay, welcome back to my channel. As we are saying, so these are the components of these are the horizontal components and the vertical component. Now, after understanding this, the next thing we are going to look at is now the what kinematics of projectile motion. What happens during motion? So that's what we are going to look at now. So let me clean this. Kinematics of projectile motion. Okay. So the first thing we are going to look at under this is time. What happens to time during projectile motion? What happens to time during what? Projectile motion. For us to understand this, we are going to look at this time in what? In two different dimensions, or using what? Two different cases. The first case is the time it takes that object to reach the maximum height. That is, time taken to reach the maximum height. Denoted as what? T max. Time taken to reach maximum height into T max. What happens to the time it takes that object to reach what? Maximum height. For us to understand this, let's go back to our what? Our projectile motion. Don't forget, this is along y-axis and this is what? Along x-axis. The object is what? Is moving. It's got what? To a particular what? Peak. To a particular point. It now what? Started decelerating. It started what? Coming down. Something like this. It started coming down. So this is what? The maximum height it can reach. At this maximum point, what happens to what? The velocity. At this maximum point, I can say that the velocity there along what? The y-axis equals 0. Why? There is no more what? Velocity at that maximum point. There is initially is what? It is moving what? With a particular what? Velocity. But when it goes what? To the maximum point, I can say that what? There is no more what? Velocity. Why? The velocity along the what? Y component becomes 0. At where? At the maximum height. If that is the case, it means for me to understand which of those equations of motion I'm going to use, I'm going to what? See the equation that connects velocity to time. I want to see the equation that connects what? Velocity to what? Time. In our equation of motion, the only one that connects velocity to time is the one that is given as v equals u plus at for my equation of motion. So now, let us now treat this equation in what? In two dimensions. That is, in terms of the what? Y component and also in terms of the what? X component. Don't forget, velocity along the what? Y component is 0. That is, Vy equals 0. So this can be written as Vy equals our u along the what? along the y component, which is given as u sine theta. What happens to a along the what y axis? A becomes what? Minus gt. This thing we are talking about is not ordinary time. It's the time that is what? Maximum, that is T max. The time it takes that object to reach the maximum height. Since dy, velocity along the y axis equals 0, this can be written as 0 equals u sine theta minus what? Gt max. So that if this goes to the other side, it becomes what? Positive. So that I can write this as gt max equals u sine theta. Therefore, we can now see vividly that our time taken to reach maximum height, T max, cannot be expressed as u sine theta over what? G. This is the formula to what? To find the time it takes an object to reach the maximum height during projectile motion. Also, that's what the case 1 in terms of what time taken to reach maximum height. The case 2 that we are going to look at is the time of flight itself. The total duration that object use during motion, which is called what? The time of flight. The case 2 will be what? Time of flight. Time of flight. Number 2, time of what? Flight. So let's call this what? Capital T to denote time of flight. What do we mean by the time of flight? So this is what? Time taken for an object to be in motion. This is what? The time taken for an object to be in motion. That's what? Time of flight. So what are we trying to say here? It means that, let's look at this again from what? From our projectile. When the object was starts, let's say it starts with what? A particular what? At a particular time. Initial time when t is what? 0. Or let's say when t is what? Start, the starting point. And what? This final point will become what? The time it what? Stops. So we can see that the total duration of that motion when the object starts to when the object stops. That is what we are what? Interested what? In. We are interested in the total duration in which the object used from the starting position to the what? Stopping position. If that is the case, then I can see this as what? As the distance between what? The starting point and the stopping point or displacement. This can be seen as either distance or displacement. That is the interval between the what? Starting and what? Stopping. Let's call it what? Displacement. Either we call it distance or we call it what? Displacement. That means for me to what? Understand time of flight, I want to what? Relate time to what? Displacement or distance. So now let's go back to our equations of motion. Which of those equations relates time to distance? For us to understand that, it means we are using s equal to what? Ut plus half at squared. This relates what? Time to displacement or distance. Don't forget, the time we are talking about in this case is not ordinary time. It is not T maximum, but what? The time of flight, capital T. So that I can now write my what? My equation that will describe that in terms of what? The two components, y-axis and x-axis, as the component of what? Of my time, of my displacement along y-axis, which is the same thing as what? Y, isn't it? So this can be written as y, can be given as what happens to you? The displacement along the what? The horizontal axis. And what happens to you along the what? Vertical axis. So here, our y becomes, what happens to you? Our u becomes what? U sine theta. Our u becomes what? U sine what? Theta along the what? Y axis. U sine theta t. Ut, since it's what? The object is going against gravity, the a becomes what? Negative g. So that means what? Don't forget the t we are talking about here is not ordinary t. It's what the total time of flight. Let's call it what capital T minus 1 over 2 g capital T squared. Where that capital T is what? Time of flight. So that this can be written as y equals what? U sin theta t minus what? Half gt squared. If that is the case, we know that what? Our y is what? 0. Our displacement along the what? Vertical component is what? 0. Why? Displacement only occur along the horizontal component. There is no displacement along the what? Y axis. From that diagram I showed, the displacement only occur along the what? X axis, along the horizontal. Therefore, displacement along the y axis becomes what? 0. Equal to what? U sin theta t minus what? Half gt squared. So that if this comes to the other side, becomes positive, the whole of this can be written as half gt squared. Half gt squared equals what? U sin theta. Don't forget this is what? Capital T. Half gt squared equals U sin theta. So that from here there is t squared, there is what? T. This t can cancel this t. So that this remains what? Half g only one t equals what? U sin theta. Which in which our time of flight, capital T, cannot be written as what? U sin theta. Okay, this 2 can also what? Goes to the other side, becomes what? 2. 2 U sin theta over what? G. Our capital T is now what? 2 U sin theta over what? G. When you multiply 2 by 2, that means our T equals to what? 2 U sin theta over what? G. This is the time of flight of a projectile motion. Again, what do we notice here? We notice that our maximum time taken to reach the maximum height is expressed as U sin theta over G. And when we solve for the time of flight, we are getting what? 2 U sin theta over what? G. It means that I can what? Relate the time of flight to the what? Time taken to reach maximum height. And the relation that exists between them is that our time of flight, capital T, is the same thing as 2 multiplying the whole of this is the time taken to reach maximum height, T maximum. So this is the relationship that exists between the time of flight and the time taken to reach maximum height. Thank you.